Now for naming esters. So esters are actually created when you combine the two previous organic compounds, carboxylic acids and alcohols. So when you take a certain carboxylic acid and a certain alcohol and you react them together, it creates an ester. This is known as esterification, to create an ester. So esters give off, so the properties, they give off aromas. So the smells that you um, are smelling are essentially esters. So the good licorice, when you smell licorice, that smell, that aroma is an ester. So fats and oils are examples of naturally occurring esters, and the ester functional group is unique. So since we're taking a carboxylic acid and an alcohol, it's going to have a combination of those two. So if you look at the ester down here, so this is the example of esterification. Okay, so you're taking an alcohol, in this case it's methanol, it can be any alcohol, and you're going to take a carboxylic acid. Okay, in this sense it's ethanoic acid. The hydrogen from the hydroxyl group on the alcohol and the OH from the carboxylic acid are actually going to leave, which creates this water molecule because your H and OH combine together to make H2O. Then what you have left is this O is missing a bond, and this carbon is missing a bond. Okay, and you have to have the correct number of bonds. So this carbon is going to bond to this O, as you can see here. Okay, so your ester functional group is the single bonded O, double bonded O in the middle of a compound. Okay, so I'm going to try and draw this out for you. Okay, so in this bubble, you're going to have a compound over here, and then you're going to have a C double bonded O, and the O with the rest of the compound, with the rest of the compound. So they tend to do R with a prime meaning rest of compound, and then R representing another rest of the compound. Okay, so again, this is in your data booklet, so if you scroll down, you can see esters right here, so you can see double bonded O, single bond O in the middle of the compound. Yes, it can be flipped back and forth, so it's just like a mirror image of each other. So I drew it with the O on this, single bonded O on this side, it can be on this side. So it just means that this came from the alcohol, this came from the carboxylic acid. Okay, steps to naming esters. So it is very important when you're trying to name esters is to identify the alcohol portion and then to identify the carboxylic acid portion. Because the alcohol portion is named first, the carboxylic acid portion is named next or second. Now the ending of of esters is ANO8. So N08. Okay, so you can read through these when you're doing examples. I'm going to do a couple with you. So we have propyl hexanoate. So alcohol always portion comes first. So when you're naming, the alcohol comes first, and then the carboxylic acid. Together, when you react these two, it makes your ester. Okay, so this portion, the propyl part, came from the the alcohol. The hexanoate came from the carboxylic acid. Okay, so I'm just putting A and CA to represent those two. So prop. If we go back to our organic chem table, prop means 3 carbons. Okay, so I'm going to draw my 3 carbons. 1, 2, 3. Now, since this came from the alcohol portion, it has to have a single bonded O. So that's what you're going to draw for the propyl part. We'll add in the hydrogens after. Now, hexanoate. Hex, we go back to our table. Hex means 6. So I'm going to draw 6 carbons on the opposite side. 1, 2, 3, 4, 5, 6. Now the first carbon is going to have the double bonded O. Okay, so the propyl, 1, 2, 3, hex, meaning 2, 4, 6. 08 is telling me I have my double bonded O, single bond O in the middle of the compound. Now you just add in your hydrogens to balance out the necessity for carbon to have 4 bonds. So this carbon, they're bonded to each other. So this carbon has 1 already, so it needs 3 more. This carbon has 2, you need 2 more. This carbon has 2, you need 2 more. The O only needs 2. This carbon has 1, 2, 3, 4, so it's good. This has 2, so CH2, 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 and then CH3. Okay. Okay. Excuse me. So number 2, octomethanoate. So oct, like an octopus has 8. So oct means 8. So the alcohol portion has 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's representing that side. So we have a single bonded O, and now we have to bond it to the methanoate. So meth means 1, so we have 1 carbon. That has the double bonded O. Okay, so this side always has to have start with the double bonded O. Well, we only need 1 carbon, so we're good. So now you just add in your hydrogens. This carbon has 1, 2, 3 bonds, so we need to add 1 more. So now let's start on this side. The end one always needs 3. Okay, now I'm going to kind of condense this even more and not show the bonds, but this carbon is bonded to 1, 2. So H2, 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 needs 2 more, 2 more, 2 more, and 2 more. Done. So you can try 3 and 4 on your own. Okay, and I'll do 2 examples for going from formula or structure to name. Okay, so I'm going to use 2 highlighters. So I have to identify the alcohol portion first. So I find my single bond O, and I highlight the side that has the alcohol. So the blue here is representing my alcohol portion, and I'm going to use purple to represent my carboxylic acid portion. Oops. Okay, so I need to name the alcohol portion first. So I'm going to use a blue pen to represent this. So all I do is count my carbons. 1, 2, 3, 4, 5. 5 in our organic chem table is pent. Okay, so you're going to put pent to represent this part. Now it acts as a side branch, so you just put YL, pentyl. Okay, now you look at your carboxylic acid side. There's 3 carbons, sorry. So you find 3, that is prop. Okay, so you're going to put prop. You keep the AN, and then you just add O8. Now you just put it together. Pentyl propanoate. Pentyl propanoate is your final name. Okay. Okay, so I'm going to do one where it's kind of flipped. So number 6, 2 highlighters. So blue is going to represent my alcohol. Okay, so here's my single bonded O. So on this side, that's the alcohol portion. Then you find your carboxylic acid portion, which is the rest of this. So alcohol portion is named first because A comes before C. So there are 3 carbons. We already know that 3 is prop. It keeps the ending YL because the alcohol acts as a side branch. There's 2 carbons here, which is F, AN, and then O8. Now put it together, sorry. Alcohol first, carboxylic acid second. So propyl, ethanoate. Notice how I have space between the propyl and the ethanoate. So propyl ethanoate. So try 7 and 8 on your own. Okay, so try 3, 4, 7, and 8. Then you can do your practice ester worksheet, and then you can start your summative worksheet. So just to be esterification, you can put this down if you so wish, but this is just talking about the creation of an alcohol, sorry, of an ester from an alcohol and carboxylic acid combo. Okay, and I'm just going to skip this stuff, so don't worry about this. Okay, I'm going to take that outcome out, and I'm not going to test you on that. Polyesters. So this is important. So plastics are materials that can be shaped and molded with or without the application of heat. You know this. So a polyester, so many ester groups. So poly means many, ester, so you have many ester functional groups, is a polymer. So this is a large molecule made up of many small molecules. So imagine a necklace. So a necklace is made up of many links. So one link represents one ester, another link represents a different, or not the same ester, but just in a different chain. So I'm going to try and draw this out for you, just to show you what I mean. So this would be one link, that is one ester. Another link, exact same compound, but they are all linked together. Okay, so this is one ester, two ester, three ester, four ester, five ester. That makes your polyester. So bioplastics. So bioplastics are something that scientists are working on. So these are plastics that can actually break down in the environment. Now the key thing about a lot of these bioplastics is they have to be placed in certain conditions in order to be broken down. So for example, sun chips. This bag was created to be 100% compostable, sorry, but it's under certain conditions. So it has to have the right temperature, it has to have the right pressure, etc. So by throwing this in the landfill, it still won't break down because it doesn't have those right conditions. There are very few places that do have those conditions. Edmonton has one. I don't believe Grand Prairie has created one thus far. But advantages of bioplastics are pretty self-explanatory, provided you have the infrastructure available to break them down. The fact that they do break down under the right conditions. Okay, so I will do exposure in a different lesson. Please make sure you practice with esters before you do your summative sheet, summative naming sheet, and I wish you luck. Message me if you have any questions.